day, everyone. Welcome to this webinar by PIMvendors.com. I'm Stephan Spijkers. I'm the co-founder of PIMvendors.com, and today we'll be diving into circularity, as product data, of course, is the foundation behind a lot of things, but also the circular economy. With me today is Ruud Bruijckere, the co-CEO of Signifikant, and he'll get a chance to introduce himself shortly. But before we get to that, just a quick note on what PIM Vendors does and who we are. We help customers with their product data. We do that independently, so we do not implement one specific PIM or even a small portfolio of PIMs. We help you find the solutions that work for your process and your IT architecture. So we look at that puzzle that is your organization. We even take a look at what you want that puzzle to be in 5 years or 7 years or 10 years from now, and find the puzzle pieces that match that end state. And that could be a series of AI tools or onboarding tools or PIM tools like Signifikant. And we help you find that and even guide the implementation. But since we are not a technical implementation partner of 1 or 2 or 3 specific PIMs, we're able to choose out of the 250 PIMs that are active in Europe or even across the globe to find the puzzle piece that best matches your requirements. If you want more information on that, go to PIMvendors.com. Not now, stick around, but go to PIMvendors.com after the webinar and I'll see you there. 2 quick housekeeping rules or housekeeping topics. We are recording this session, so if you have to leave early, no worries. We'll share the recording with you afterwards, or you can view the recording here on LinkedIn. So if you, don't worry if you have to step out sooner. And also, we have a comment box and an open, ongoing conversation. So if you have any questions or examples or solutions, challenges you want to share, you can do that in the right-hand side. There's a comment box here on LinkedIn. So feel free to quickly introduce yourself here in the meantime. Or if you have any questions or comments or feedback, I'll try to weave that in the conversation naturally if I will not already have responded to you in the chat window itself. Now, without further ado, maybe Ruud, could you do a quick introduction of yourself and maybe of Signifikant as well?
Absolutely. Thank you, Stephan. My name is Ruud Bruijckere. I'm the Vice-CEO of Signifikant. I've been working with Signifikant now for 20 years, and we are working in the area of the aftermarket product information management systems. I'm originally from the Netherlands, but have been living in Sweden for 30 years. And I've seen that what we are working with, the aftermarket service and repair, is getting more and more important, of course. So our company really helps your companies to improve their aftermarket services, to make the life easier for the service technicians, but also to increase your aftermarket spare part sales, for instance. Yes, and today I'm very excited to discuss with Stephan what we have been doing in the area of circular economy.
Right. I mean, last time we did a webinar, we also dived in the tooling a bit. One of the videos from that webinar got viral on the aftermarket PIM part of it, because what is an aftermarket PIM? We know that product information management tooling, they're all puzzle pieces. They all cover a different part of the puzzle that an organization has to build from a feature perspective. Some focus on print, some focus on the onboarding, some focus maybe on AI or on syndication to all the different marketplaces if they are more retail focused. How does an aftermarket PIM differ, and why does it go viral on LinkedIn?
An aftermarket PIM is different than a PIM because it takes care of much more details about products than a normal PIM typically does. Because when you engineer a product and you make it ready for sales, you have a lot of information about the product. But if you have manufactured it, and you have manufactured it for several years, then the same product can be available in many different variants. You may have replaced parts. You will have an organization that have been servicing the machines or the tools. You have a service organization that needs kits to service the application or the production. You may have some emergency repairs that you must do. So there's so much more information in an aftermarket product information management system. It's not only about the products and the SKU numbers you sell, but it's also about the existing machines out there and what people do with them and how you service them. So it's just a lot more information. It's more complex, it's more detailed. But what we want is that if any customer, service technician, or anyone, dealer, reseller, looks at a certain machine, they know exactly how to service it, what parts are in there, what kits are available, what accessories are available, how you can add extra options to that machine. So it's a lot more, but it's also dependent on if that machine was produced in Hungary in 1993 or in Germany 1995. It looks the same machine, but they might be completely different. And that those differences, the information that we have in our system.
Right. So an iPhone is not an iPhone. An iPhone might be an iPhone, but even then, yeah,
Even an iPhone 10 will not be the same as the other iPhone 10 or well, yes. And certainly if it has been used for a few years, yes.
Yeah. And what kind of customers, like that's maybe the final question on this, but what kind of customers do you generally serve? Like when do you need an aftermarket PIM?
We serve typically OEMs is our biggest chunk of customers. So companies creating products, but for us, for our product to be interesting for you is that you have some kind of complexity in your product information. And this doesn't need to be that you have a complex product. We have forestry machine builders. So they have a big forestry machine. It has an engine, it has a chassis, it has wheels, it has axles, it has thousands of spare parts. So there the complexity is in the product itself. But we also have customers who make simple products like screwdrivers, industrial screwdrivers. Atlas Copco Industrial Engineering is a customer from us. They make screwdrivers that are used to, for instance, to build a car or to build an airplane. And then every time you fix a screw, it notices how hard you have screwed it, and it will record that, so that afterwards, hopefully not, if the plane would fall from the sky, they can say it's not our fault because we have turned all the screws correctly. And in this case, the complexity is in a lot of variants. They have a simple product, but there are many variants of the same product, and they have installations of products. So it's from simple products with a lot of variants to complex products, or we also have customers who typically buy a lot of other companies who produce in many different countries, who have different PLM systems, maybe Excel, maybe Word. But for an end user, for a reseller, a dealer, a service technician, every product should be the same, should look and feel consistent to the information you get about the product. So that's what we do. We take this heterogeneous landscape of information and we show it in a way that whatever product you're looking at, wherever it's produced, whatever the original company was, it will look and feel the same. So That's the type of customers that typically come to us for aftermarket product information management system.
Right. But that could even mean that you sit on top of an existing PIM or even operate within an ecosystem of different PIM systems across many different business units, or directly sit on top of the ERP, or even integrated into the PLM. So it doesn't really matter. Yeah.
Absolutely. We typically we aggregate information from many systems. We don't produce information, we aggregate information. Some information is owned by us. For instance, if a customer wants to create the service kits in our system. But if you look at a part, it's possible that a part of the information about the part is coming from the PIM system, a part is coming from the ERP system, the PLM system. So the engineers, they've given it a certain name, but then the ERP system, the people from marketing and sales, they want to give it a different name to make it easier to sell it. So we always keep track on who owns what data. And once they have given that data, it's not overwritten by anyone else. If the engineer comes back and wants to call it something else, it's not. But if the marketing department hasn't done their work yet, then it will have the name, for instance, that the engineer has given it. So yes, we are also integrating with what we call normal PIM systems to sell the goods, to integrate, for instance, market descriptions into our aftermarket portal.
Right. All right, cool. I mean, we're going to talk about the circular economy today and how that foundation of product data is well, critical for all the use cases and the management of aftermarket installations and tools and complexity, as you have just described. But product data is also the foundation for that circular revolution or transformation that we are going through. It is a rocky road, I think. It is very much in development. It has seen its fits and starts, but it is definitely getting there. But maybe let's start with first the definition of what we mean by circular and what we mean with the circular economy. If that is, yeah, could you answer that? What is the circular economy?
It's an economy. Well, the most simple definition may be that you want to reduce waste as much as possible, and that can be done in multiple ways. But yes, first of all, is reducing waste as much as possible. That is the end goal. And you can do that in many different ways. And one thing, what we as an aftermarket PIM provider have been working for a very long time already with, well, we started basically in 1994, is the longer use. So just make it possible to repair and to keep products and machines and tools alive as long as possible. That is the first thing you want to start in a circular economy. But the next thing is that you can look at a machine or a tool and say, okay, there are a lot of parts in it that are still very good. We want to remanufacture, we want to refurbish, we want to take this machine that comes back from a customer and we want to make it as new, and we're going to sell it on the market as a remanufactured machine. Or we're going to take out a very important component, the heater, for instance, in a printer, and take it out and refurbish it so that it can be used in a completely new printer. And then when the product has gone through a number of life cycles, we can go and say, okay, but then in the end, okay, we break the product down in the pieces, in plastic, in metal, in all the material it has, and we do the recycle and we build the product from the start again. But what we absolutely want to avoid is the waste. Unfortunately, we do have examples. We've been working with this quite a long time, but we've seen some partners that we've been working with. For instance, a refrigerator. It is sold to a customer. The customer, for some reason, doesn't like it. Bring it back within the time, guarantee time. The refrigerator is brought back, and it's basically completely recycled because for some reason in the old linear economy, it was cheaper to just build a new refrigerator than actually try to reuse that refrigerator. So we have been working in several research projects with several partners in a number of ways of getting this circular economy up. So, and one of this is to go for a service-based business model. So here we have an example of Gorenje. We started already 10 years or maybe 12 years ago together with them, where they make white goods. They make washing machines. What they said is, okay, they are very cheap, and if you would take it very harsh, best for them would be if they break down like 1 month after guarantee is gone. But you don't want that, of course. So they wanted to go for a service-based business model, which is one way to achieve a circular economy. Because what it does is that you can choose. You can choose for a pay-per-wash model instead of buying the machine. And what they then did together with us, because we provided them with all the data and with an integration with an IoT platform, you keep an eye on all these machines, and you know when you need to repair them. You can repair them preventively, but also you can do it in a way that if you want always the newest machine, you sign a gold contract. You get always a new machine, and after 3 years, the machine will be replaced by another new machine. Then you have people who have a silver contract, and they will get a machine that has been 3 years at a gold customer. And then you have a bronze contract, which will go to a student house maybe, and they will get a machine that is maybe 6 to 9 years old, but still good because it is maintained by the company who actually has created the machine and who's actually getting the money by a paper wash model. So that's one way, but we have more ways that we have been working with circular economy. But maybe Stephan, you want to ask something more in between?
Well, it is something I think we're struggling with, right? It is not just, and of course, if the audience has questions, they can ask as well, and I'll try to weave those into the conversation. So, but something we're struggling with is just a new sort of model of business, a model of finance, a model. It takes the whole system to realign around a new way of doing business, a new sort of economy, and you need the tools to do that. And I think that is super interesting. You need that vision, but to make that vision a reality, yes, you need the law, and I think some of parts of it have been signed into law, but you also need to make it possible. So it's cool to see how that is made possible.
Yeah, and I can tell about you say, well, we need to change our way of thinking, and we have a law. I think also that a lot of people, they are very interested in it, and a lot of companies want to do that, but there also needs to be some kind of market for it. And that's another example. We are involved in a European research project called DSIM, and the sole purpose is to stimulate, to increase the reverse flow so that all these arrows that go to the left, to increase that. Another one that is that there's a company in Germany called CECO, and what they do is they've made a market platform for options. So they know there is an interest at remanufacturing, refurbishing companies to get certain cores, get certain components from cars. But the people who have those cores, they don't know about this demand. So basically the same as a stock market, they make an option market for these cores. And they put together the companies that actually are interested in these cores with the companies that are repairing, which are taking back cars, that they actually have access to these cores, just to make this market bigger and bigger and show this interest. And where we come in there is that we have an aftermarket platform. So if I'm a service technician, I use our platform to remove a certain core and then to buy a new one. What we do is then we connect to this CECO platform, and we get the information. Hey, wait a moment, there is actually an interest. There is an option for this specific type of core. And if you have one, you can get this amount of money of it. Do you want to take this option? And then you can take the option, and at the same time you buy a new core, you leave your old core, and it goes there. And also it is a way of not having to send back your core to your dealer that sends back to the distributor that sends back, and so you also is a way to reduce the traffic. the transportation of these cores.
Yeah, so you decentralize that part of the transaction, basically.
Yeah.
It's that is super interesting that you are. So if I get this correctly, you also facilitate the transaction in that sense. Like it's not just a PIM as in a system of record, but it is also, or maybe not a system of record for that transaction, but you facilitate that transaction. Is that correct?
That's correct. So also in our aftermarket platform, we provide the information, we provide the catalogs, the parts, and everything. But we also all integrate with ERP systems, with web shops, so that you can buy new spare parts. So that's still part of the, you would say, the linear economy. So, but now we also take it one step further, where we also enable you to actually to book your return and get that returned. Yes, so that's true.
Yeah, it's interesting that you say you have the linear economy versus the circular economy, but I also think you get the sort of more centralized flow of the linear economy to a more decentralized flow of the circular economy, where instead of, as you mentioned, the distributor distributes everything, or you push it back up the value chain, you get this decentralized redistribution of spares or parts. I still think that you need to have this like foundation. So where I'm curious about is like, how do you track all that data, and where does product data fit into that traceability of a core or of any spare part through that whole journey?
Yes, because every step you see here, every step to the right and every step to the left, data is the most important thing, actually. I was already told a little bit about the product data. You want to know exactly if I want to send back a component, then the remanufacturer needs to know for 100% sure that it's actually interesting, that we can actually use it. And there are so many factors that are important there. It could be the year that this product has been made, and also the exact product number of that component that's in there. But it could also depend on how much has this machine been used. If it has been used for 10 years in a mine with a lot of dust and very harsh conditions, or if it has been standing in a garage of an old lady, that's a big difference. So also the usage of the tool, and then there can happen things. So all that data, and within this DSIM project, we call it the Open Access Digital Platform, which is a platform which has open access. It is APIs. It's open for companies to join this as a participant. That all that information is stored there. And this can also be, and that's part of this project, that the remanufacturing wants to see some pictures, and that they will use, or they are using, optical character recognition with AI to check if how good is this part, is how bad is this part, and are we actually interested in it? Because if we can, if you send it back, it can be a long transportation. So we don't want to send back parts or tools or products that cannot be reused. Then it's better that you go to the nearest recycling center. So a lot of AI is of course used nowadays. You cannot come around that, to determine the state of a part, a product, but yeah, and also we have this platform with all the data. It's the data about the product model, about the asset itself, the serial number. It can be data about claims, what has happened with this with this product. It can be data about options that have been added, parts that have been replaced in the past, and so on. So yes, data and aftermarket product information is key to make this work and to also to reduce unnecessary transportation.
Yeah, I mean, getting insight into that product data is, I think critical. My most recent refurbished purchase was a used hard drive, which was factory recertified, but there was no data on how often it was used or how much hours it was used or any of the sort. I would have loved to have that data to make a purchase decision on whether I should do this or not. And I can imagine that if you are, I don't know, buying some mechanical part that has been used in a mine, you'd rather want to know that before you do that versus when it has been part of the home of an old lady or has been standing in the garage of an old lady. So I think that is super important, but also super data intensive, right? So how does that work, and what are the challenges that you see in managing all that data and communicating all that data?
Yeah, there are of course a number of challenges. Security is the first thing that comes into mind. There's a lot of data, and some of it is intellectual property of an OEM that only should go out to people working within that company. Other information maybe should go out to their dealers and resellers. Other information may be of such character that you by law must make it available for everybody, or at least for other service companies. And then there's data that should be available for everybody. And also, as a push for this circular economy, I think companies that are interested in this, they also try to push more and more information to be more openly available. Yeah, so security is one thing. Of course, you already mentioned also the amount of data. So we really have to have a good platform and scalable structure, which we definitely have. We have customers who have more than 2 million parts in our system. So I don't think there are many customers who have more than that. And then you need a very good structure. So you need a very good base structure. We have a structure that has been grown from 1994 when we started, 2004 when we started the Signifikant platform. The base data model is still in place, but then on top of that, each customer, each user can build their own business model. So they can, based on the base structure, which is we think is almost perfect. Nothing is perfect for the aftermarket. You can build your own, because we don't call it catalog, we call it book, and we have 5 different types of books, and there are different rules for these books. We have different types of parts, we have different types of kits. So all that you can decide yourself. So we have a platform that's the same for everybody, but it's configured and set up in a way that it fits exactly the needs of your company. And then, of course, the integrations that you need with your ERP system, your PIM system. So it's in that sense many users, but the core is the same, but the solution is always custom, or not custom. It's configured to your needs.
Right. But I mean that, like, in the end, everything is data and database tables, right? But it still really depends on how easy you make it to access it. Like the most valuable data can be worthless if you cannot access it or you cannot find it, or when you make it really difficult to connect to or download or access that data, or when it is improperly structured. So I'm curious how you then facilitate that communication and how that helps the circular economy. Like, how does that facilitate the communication?
Yes, I think that mainly the most important thing is to make the data available through many different channels and in many different flavors. So if we look at the data we have, and we have many types of data. So I already mentioned product data, serial number, asset data. We have the data about claims. We have users, organizations, discounts, data about usage. So everything is available, of course, over our own portal, which is also can be styled and organized exactly as you want it. But then the data is also available through multiple APIs. So basically, the open access digital platform, there is a part that's the core data. And anyone who wants to make any changes to it needs to go through an API, even our own tools. So it's always it's one channel in for each type of information. And the important part of that is that in that channel in, there is always rules, validation rules. It should match your setup. It should match your way of having data. If you say that this specification is mandatory for each part to have, if each assembly, each kit should have an image, then we make sure that it's like that. And if it's not like that, you may still be able to maybe to save it, but you will not be able to publish it. So we have the core data. You can see it here in the middle, the product information, the serial numbers, the claims, the forms, the users, organizations. Then we have these APIs, and then we publish that either to our own portal. You can manage it to our web manager. So from the internet, you can manage all that information. You can manage all the structure of the information, but also because these are open APIs, you can integrate it with your web shop. So that, for instance, you're making an engine. Scania is making engines. We work with Scania. We build, maintain their aftermarket solution to take care of all the trucks and all the parts and all the standard times and so on. But they also sell just engines. So if you have, for instance, do it that way, then another OEM who makes a forestry machine or a small truck and uses the Scania engine, they can use these APIs to get in the information in their web shop. So you can, in their web shop, you say, oh, I have this Scania engine, and you can see there also all the information that Scania wants to share with you. Then we still have opportunity to create PDFs. You can also create the PDFs from the portal if you like that. These open APIs also allow you to integrate with other systems, for instance, training systems, which says that if I'm in the training, I can, during the training, use the data, but also when I finished my training, I will get access automatically to more data in this platform. So it's extremely open. And as you said, that's important because data should be available. It should be available in an understandable way. So there's also master data with reference tables so that people don't make up their own values for certain specifications. And it's very can be used in many different industries. So we're not industry specific. You see here four different industries that we work with within this European project: washing machines, refrigerators, printers, cars. But we have a lot of customers in agriculture, tooling, forestry.
Yeah. And how, like, if I see this, I would say, oh, this looks like a data pool structure. I know some centralized data pools like One World Sync or some of the GS1 data pools that are countrywide data pools, but still, how does that differ, or would you be able to contrast the GS1 data pool or the One World Sync data pool to the open access digital platform?
I think there are a few things. One is that it is completely the underlying data structure is specifically made for the aftermarket, and that is different. That allows you to handle, as I already said, kits, replacements, very difficult replacement structures. It also allows you to handle products that are configured very. If we look at Scania, They have maybe produced 3.5 million trucks, but of every truck there is maybe 2 other ones that are exactly the same. So we also support our data structure also supports extreme configurability, and that you really, when you look at your specific machine, you only see the data that you are interested in. On the other hand, also, I think when it comes to security, we allow, we make it easy also for our customers to to have this on-premise, so they can run this fully in an environment that they feel safe with. So that they see this is our intellectual property, this is the most important data of our company. So it can be open, but it can also be on-prem. But I think the most important difference is the data structure and the configurability of that data structure for your aftermarket. We really are niched on the aftermarket. That's our thing.
Right. Okay. So, but so if you would start using this digital platform, you would be using your product data model, basically.
Yes, absolutely. We will adapt that to it will be your own model, definitely, and it will, especially we focus on the process. So we not only focus, because you mentioned it's very important that the data is consumed in a good way, but even more important is that the data is produced in a correct way, and that the quality of the data is 100%. But for many of our customers, their aftermarket business is a big part of their business. It can be even more than 50%, up to 65%. But what they see is that they have competition that are trying to go for the high sellers, the gray market, that are selling spare parts for them. The way for them to compete with this gray market is to have always exactly the right information. So your data quality is super important. So we not only have this open or this data lake, as you would say, but we also focus very much on the processes to create the data, to work with data quality. We know that most of our customers, they have data from 30 years back. So it is a continuous process to improve the data quality, but especially new information that you put in, it should be correct from the start. So and we can help with that, because we can visualize, we can make reports. We have another research project supported by the Swedish Vinnova on working on using AI in the aftermarket, and we see big potential. Actually, we already can help our customers in finding anomalies, inconsistencies in their aftermarket data. Right now, we are presenting it, and we are proposing changes to the data. Maybe in the future, it can be more automated. However, as said, it must be always correct. So when it comes to AI, we really want to use AI in a way that it supports, but we want no hallucinations. We don't want it to propose a part that it's not correct. That's why we, when you search for information, you search directly in our data, and not using an AI to make some kind of assumption that probably you can use this part. So we use AI a lot, but mainly for improving the data quality and helping in the data import at this moment.
Right. I mean, you make it sound easy if you say, "Hey, the data quality should be good," but I know from experience that it is. Well, I don't want to say never, but it is. There's always something that can be improved, and I do think that now with the advent of artificial intelligence, and specifically some of the niche models trained for these specific technical products, or even the niche models trained on non-specific technical products. But with this sort of next stage, we are getting to, still you need the human in the loop, I would say, but we're getting to a situation where you can just leverage the power of AI to cleanse all that data and enrich a lot of it manually.
Yes.
But then still, I think there's manual effort in getting all that usage data in. Or do you also pick that up from, I don't know, sensors on the excavator, for example? How does that work?
Oh yes, definitely. So we do have the possibility to connect to the machines and store that information for each machine and to use that information, for instance, for preventive maintenance. So yes, forgot a little bit the question, I think.
Like you can't see on the outside whether it was taken from a mine or taken from that old lady's garage.
Yeah.
But you basically then interface with sensors on the device itself, or the camera that the old lady has in her garage to check if it has been actually used and how much hours it has been. No, but with the sensors on the device itself, and that is imported into the digital platform.
Yes. So exactly. So if you look at the picture at the top, we see Lexmark printers. Lexmark is a company we work with within this DSIM project. What they do, they want to increase the number of printers that are taken back for a second life or a third life. For that, they are working with printers that are connected online. For these printers, information is collected continuously. What happens then if someone wants to send back these machines? They will go into the open access digital platform that we've set up. They will open the part, and I can maybe see if I can show this one. Yes. Here we have the front end of the open access digital platform, and they will go into the Lexmark forms portal, and they will fill in a form, basically that okay, I want to get rid of these machines. These are the serial numbers. What happens then is an automated process will start where the information or the serial numbers are sent to a data team, which gathers all the information from that specific printer or those specific printers. It will then go to a machine learning, or it will go through a machine learning network, which is learned by the University of Ljubljana. So this is part of research projects. It's not used in production yet. But the next thing is that the machine learning project will say exactly what you say based on everything we know about it, all the data we have collected about this printer. It will say, okay, this one is good enough. We can take it back, or we can actually buy it back for €50, or we take it back for free, or here is the nearest recycle center, and please go to that recycle center and leave it there. So that information that you said, the usage of the machine, the conditions it's been in, how fast, for instance, it would heat up the toner, how long it took for that. So there are a lot of indicators that are used to determine the status or the health of the different components. In this case, there are three important components. I think there's one heater, there's one roller system, and one other. I've forgotten the names about them, but those three they are most valuable, and they can often be reused. But also, we don't want to send them back if they're not going to be used. So that is done all in the open access digital platform, and as you said, Stephan, it's actually based on the actual usage of those machines.
Right. Okay, that is more complete than I would have expected it to be. But that is, of course, the information you want to have with the amount of human labor you want to have. Because if someone, I don't know, would be tracking all those prints manually, right, it would be totally unmanageable from a cost perspective, for printers at least. And of course, you have to trust the data. So having that constant connection to count the usage does make sense from a tampering perspective. So you know that it is the real use case. Someone did not like change the numbers in the machine or did anything with the counters. So you have a machine that is being correctly used. On the other hand, that immediately raises some security concerns on my side. So you already mentioned the security aspect of this. That is, it is always a trade-off, I would say.
Yeah, and there are also, of course, printers that are not connected to this system. And then it is actually possible also to create a process for that, because those machines, they keep these kind of statistics also in the machine itself. So when you create a form, it's possible to extract that information actually also from a machine that has not been online, but that has been offline. It's not as much information, but it could still be valuable to determine the value of this printer, and if it's worth to bring it back, if it's even worth to pay something for it, or that the best thing is to actually bring it to a recycling, or maybe use it a little bit longer.
Yeah. So and this is a great example with Lexmark on using this in practice, even though parts of it are still more in the research phase of this. Do you see any other examples or cases where this is currently being implemented, or where you think this would be a very good use case?
Yeah, so if we look here, we have Arçelik. It's down there. They create refrigerators. I gave the example in the beginning that a lot of returned refrigerators are actually recycled, which is very bad. They now try to do something which is a little bit better. Best would maybe be if they got a new life, but we now have a way of taking these back, recording them in our open access digital platform, in our aftermarket PIM, and then we know exactly what parts and components these have. And when there is a need for a certain part of component, they are actually taken out and reused. So that's of course one thing you can do. The other example we see here is from Gorenje, and that is very much on changing the business model to a service-based business model. And also there, it's very important that you have the information of the machines, that you're using AI to detect and determine when a machine is going to break. We, as a company, as Signifikant, we don't provide the AI technology. There are other partners working with that, but the results and the outcome is stored into the open access digital platform, so that it's available and can be used for taking the next steps to plan, for instance, for a service or something like that.
Yeah, it's we're getting here, right? I'm not sure if we'll be getting at my use case with the hard disk drives anytime soon, but I do think that this is, we're getting to where it needs to go. And I'm glad that we're doing this and trying to fix the circularity issues and do more about the reuse and the recycling. It makes sense, right, that we should be doing this, and I'm glad that we have now the tooling and the research to support the process, instead of just great visions and some regulations that are signed into law. With that, I'm not sure if we have any questions from the audience. I haven't seen any interaction yet, but if you do have questions, please let me know. Or if you don't want to dare and share your question publicly, you can send me a private message or send one to Ruud. We'll even be happy to take those questions after the webinar has ended, so feel free to reach out. Maybe any closing thoughts on that side, Ruud?
Yep.
Any things you have where you would say, hey, this is where you would start, or yeah, the
Absolutely.
next.
First of all, this was meant to be a discussion, and I think it has been a discussion. So it has not been a presentation or demonstration. So if you're interested in that we demonstrate this, please contact any of us. And we can book that because, well, it typically takes a lot of time, and it was not the purpose of this webinar. And then if you're going to do this, we've talked a lot about data quality is important, but we also see that data quality is a never-ending task. So it's not something you should wait until your data is perfect and then look if there is an aftermarket platform to publish that perfect data. Adopting an aftermarket product information management system is a step on the way of improving your data quality. Because then you have an overview, you have a structure of the information, you can more easily, for instance, use an AI tool to find anomalies, but you can at least start and get out your aftermarket information, your spare parts, your kits. People can start ordering them through the internet instead of calling you and you have to go into an Excel sheet and find them. So don't wait. Dream big, but start small. That's what we always say.
That's great. I think, yes, data quality is a whole beast in and of itself, but I agree with you that that is often the place where people should be already working on, and if not, can start tomorrow or can start today. I think it is great that we have seen sort of maybe even though we didn't see the live demo or something similar, it is great to have something that is a bit less abstract, where many of the laws and regulations, many of the examples and visions are very abstract, very much, hey, this is where we need to be in 2 years, 3 years, and then suddenly next month. And this is really interesting in making it more concrete, making it more real life. And I think it didn't even need to be a real life demo, but if people are interested, I would say, please check out your website. So, and I'll share it in the comments, but also reach out to Ruud on LinkedIn, or if you have any other data cleansing issues, reach out to me on LinkedIn, as we do have some interesting AI focused partners that we can connect you with. I don't have a vision like yours, at least not as compact and nice to wrap up with. But I do want to thank you, Ruud, for the quick
Thank you.
non-demo but great introduction, I would say, to the open access digital platform that you guys are building and how we are now moving ahead with circularity. I've shared the link to Signifikant on the comments so people can find you and the solution there. I did share a blog article, I think, but that's all right. If people have any questions, they now know where to find you. If they want to request a demo, for sure, please do that. Or rewatch one of the earlier episodes that we did with you, where we also focused on the interesting additional puzzle features that an aftermarket PIM brings. And if you want to stay posted on the other developments in the world of PIM, from data cleansing and AI to regulatory changes like the digital product passport, please follow us on LinkedIn or visit pimvendors.com for our free resources there. Thanks for sticking with us today, and hope to see you soon. Thanks a lot.
Thank you.
And
It was a pleasure.
see you soon. Thanks. Bye-bye.